Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening, children. Yeah, please help me. Should we continue from here? I need to explain this, right?
Yes, ma'am.
Yes, ma'am.
Yeah. All right. So here, AD, BE, and CF are altitudes of triangle ABC and are equal. So the given triangle ABC is just a triangle, meaning we do not know the nature of the triangle, whether it is isosceles, scalene, or just, isosceles, equilateral, or just scalene. We don't know. We are given that the altitudes are equal. AD is the altitude on the side BC. BE is the altitude. Okay, let me make it more clear. AD is the altitude. This is also 90 degrees, children. This is also 90. AD is the altitude from the vertex A on the side BC. BE is the altitude from the vertex B on the side AC. CF is the altitude from the vertex C on the side AB. It's given that the altitude AD is equal to the altitude BE is equal to the altitude CF. We do not know the nature of the triangle. We are just given its triangle ABC. But the altitudes, the three altitudes of the triangle are equal. Given this, we need to prove that the triangle is equilateral. That is, in a triangle, if the three altitudes are equal in length, that means the triangle is equilateral. That's what we have to prove. Is the information given clear?
Yes, ma'am.
Yeah. Yeah. Now the proof is still easier. It's easier than the information given. Now see here, I think I was telling you the other day. So how do we, how do you consider the triangles? Which two triangles to take and, show that they are congruent? So that is very important here. Before that, so I have to tell you that to prove that the triangle is equilateral, you don't have to prove that the three sides are equal. Like you don't have to necessarily show that AB is equal to AC is equal to BC. You can even show that angle A is equal to angle B is equal to angle C. To show that the triangle is equilateral meaning all the three sides are equal. So that means we'll have to show that AB is equal to BC is equal to AC. If you cannot prove this, you can prove that angle A is equal to angle B is equal to angle C. Angle A is equal to angle B is equal to angle C. This way also you can prove that it's equilateral. Okay. So now how to consider the triangles? We need to get these results. We either have to get AB is equal to, BC is equal to CA or AC, or we have to prove that we have to take two triangles, get this result angle A is equal to B, take two other triangles, get this result angle B is equal to C. So once you get these two results, it's clear that all the three angles are equal, so all the three sides are equal. Okay, so now how to consider the triangles? So it's like this. Now, what you'll have to understand is you cannot take up the whole triangle ABC because you know that the whole triangle ABC cannot be congruent to any other smaller triangle here. The whole triangle ABC cannot be congruent to any other smaller triangle here. See, we have smaller triangles like ABD, ACD, BCE. We have many small triangles like that. ABC is that whole triangle. Now, nowhere in congruency you can take up the whole triangle ABC, because with ABC, what other triangle can you take? If you take up the whole triangle ABC, it's congruent to what you can prove. You cannot prove it's congruent to any other triangle because the others are smaller than ABC. Congruency means equality. No triangle is equal to ABC here. So you cannot take up the whole triangle ABC. That's one thing. You cannot take up the whole triangle ABC. Okay, so that means, see the smaller triangles you have ABD, you have ABD, and you have okay, let me tell you like this. With respect to the altitude AD, With respect to the altitude AD, we have ABD, ACD. With respect to the altitude BE, we have BCE, BAE. Okay, 1 minute. I think I should make it more clear. 1 minute. Let me write all the altitudes. 2 times I'll write it, okay? I'll write the altitude 2 times. AD, AD. Okay, then the other altitude, BE, BE. Then the other altitude, CF, CF. Now complete the triangles, children. Now complete the triangles. AD, AD,
B, ma'am.
B, AD,
C, ma'am.
C, BE,
C,
C, BE,
A,
CF,
B, ma'am.
B, CF,
A.
A. So these are the 6 triangles you have. These are the 6 triangles you have. So you have to take, so you can take this pair, or this pair. Take up any 2 of these 3. That's all. I think I've made it clear like this. So like this, you can take 3 pairs, you can take 3 pairs. We have taken, see here, I have taken BC, I have taken, what is this, BCE and BCF. Okay, this way also. Okay, I've done it in a different way here. Let me tell you like that. Okay, these are the 6 triangles, student. These are the 6 triangles. Do you understand that? These are the 6 different triangles you have here. Is that clear? Okay. Yeah, these are the 6 different triangles. So let me write it again. With respect to AD, we have ADB, ADC. With respect to BE, we have BEC, BEA. And with respect to CF, we have CFA and CFB. So these are the 6 triangles we have here. These are the 6 triangles. Remember, we cannot take up the whole triangle ABC because with that you cannot take up any other triangle and show that they are congruent. So you cannot take up the whole triangle ABC. Okay, now let me tell you what I've done here. So I have taken up triangles, which now I think I better write than saying. Now, if I take up BC, I'm taking the triangles with respect to the sides here. So if I say BC, with BC, how many triangles can you form? See here, AB, BC, and AC are the 3 sides, right? AB, BC, and AC are the 3 sides. Yes or no? Of the triangle. AB, BC, AC. All right. Yes. Yeah. Now with BC, you tell me 2 triangles with BC. With BC, you tell me 2 triangles.
BCE.
BCE.
BCF, ma'am.
BCF. I'll tell you the reason also why. See, the reason is actually you can take any 2 triangles. The thing is, you should have more information to show that they are congruent. So when you take triangles like this, BCE and BCF, BCE and BCF, already you have a common side there. You already have a common side. That's one advantage. And in BCE, we have the altitude BE and 90 degrees also we have. See how we consider the triangles. We take 2 triangles such that we have a lot of information there to show that they are congruent. See, we have a lot of information, but if the choice of the triangles is incorrect, then you may not have information to show that they are congruent. That's what it is. We may have sufficient information, but if your choice of triangles is incorrect, you will feel that no, I don't have sufficient information to show that the triangles are congruent. So that is the smart work you have to do here. You'll have to consider 2 triangles so that you have maximum information in that. So now why have we taken BCE and BCF? I said with respect to the side, BCE, BCF. BCE, BCF because BC is a common side now. BC, common side. And in BCE, see here in triangle BCE, you have the altitude BE. BCE, you have the altitude BE. Altitudes are equal. See, already one common side BC is there. Altitude BE is there. The altitudes are equal. And altitude means 90 degrees. So see, 3 things you have there. And in BCF, BC is the common side. CF is the altitude. So altitudes are equal. And then CF, so 90 degrees. Understand, children, what I mean?
Yes, ma'am.
Okay, so we choose the triangles like this. BCE, BCF. See, with respect to the side again, ACD, ACF. With respect to AC, Which are the two triangles with respect to AC, ACD, ACF, isn't it?
Yes, ma'am.
ACD, ACF. Just a minute, children. There's somebody at the door. Just a minute. Yeah, children. So with respect to the side AC, we have ACF and ACD. So do you understand the choice of the triangles?
Yes, ma'am.
Yes, ma'am.
And you should not take up the triangle ABC. Remember that also. You should not take up ABC. Okay, so now when you take up these two triangles BCE and BCF, so BC, I think you can understand that. See, you look at the information, children. One is the common side, okay? BC is the common side. Then the other thing is that the altitudes are equal. The altitude BE is equal to the altitude CF. That's the other information. And then 90 degrees in both the triangles. So right angle, BC happens to be the common hypotenuse. Common hypotenuse. Here, I'll draw the triangle BCE. This is BC, this is BC, and this is E. Okay, this is E. This is BCE. All right. And the other triangle, BCF. See, this is BC. This is BCF. Okay, this is F, BCF. So we have 90 here, we have 90 here. And then this altitude BE and this altitude CF, they're equal. The altitude BE is equal to the altitude CF. This is the altitude CF. This is the altitude BE. They're equal. Then this 90 degrees and 90 degrees. And BC is a common side. BC is a common side. So you can draw the triangle separately for more clarity. For more clarity, you can draw the triangle separately like this. So you can see that opposite to the right angle is a hypotenuse. Opposite to the right angle is hypotenuse, which is a common side. So BC is equal to BC, common side or the common hypotenuse. Right angle is here, this one. And then some other side, altitude is only that some other side. BE is equal to CF. Is it clear, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah. So right angle, common hypotenuse, and some other side, equal altitudes. Okay. So RHS, they're congruent. So I showed, see in triangle BCE. That means you should not see these. Oh, sorry. In BCE, so don't see these lines. These lines you don't see. In BC, this is only BC. Don't see these two lines. This is only BC triangle. So you have this angle C, And in the other triangle, BCF, don't see these lines. BCF, no, so these lines are not there. BCF. In this triangle, you can see this whole of angle B. You can see this whole of angle B. So what is angle B called in this triangle? FBC. FBC. Angle B is called FBC, and here angle C is called ECB. See here, FBFC. See here, this one is FBC. FBC. See here, FBC is equal to, see here, FBC is equal to ECB. ECB. Name. Okay, let me write it. This angle is called angle FBC in one triangle. And this angle is called angle ECB, or you can also call it angle BCE, whatever, BCE. This is also called angle CBF. It's also called this one. So you can see here, FBC, FBC, FBC. ECB, see here, ECB. Second letter, the second, third, 2, 3, 1. Here also 2, 3, 1. So this angle is equal to this angle CPCT. If this is also difficult, children, see here, it is not, it shouldn't be. If this is also difficult, just draw the triangle separately. See, I'll show you the triangle BEC separately, okay? BEC, where is BEC? Okay, this is B, this is C. Okay, so this is BEC, children. This is BEC triangle, this is the altitude, this is the side, common side, and BFC, see here. BFC, and this is 90 degrees, and this is the altitude. Now see here, in BEC, right? Which is the triangle BEC? This is the triangle BEC. So you mark, this is B, first angle. This is E, the second, okay, let me mark 1. This is the second angle, 2. This is C, this is the third angle, 3. In this triangle, CFB, C is 1, F is 2, and B is 3. See here, BEC, I've marked 1 for B. This is 1, children, angle 1, angle 2, angle 3. So you can see here, 1, 2, 3 I've marked. Angle B, angle E, angle C. And the other triangle, it is CFB. This is the other triangle. C is angle 1, F is angle 2, and B is angle 3. So you can just match the angle. So see here, angle B. No, not this angle B, sorry. This is only, because angle B is only this part. If you say angle B, it's only this part, not this one. The full angle, this angle 3, see here, this one, this angle 3 here is equal to angle 3 here. This is only that full angle C. This is not full, this is not the whole of angle B. There's only this portion. This angle, see this whole angle here. This angle, that angle is called 3 here, is equal to 3 here. So in BCE, angle C, this one, is equal to, in the other triangle, it is angle B. In the other triangle, it's angle B. So you also have to put in little effort, children. I'm trying my best. So you should identify. See, the other angles are these two. The others, these angles, we are not taking these angles. You should put this whole angle is equal to this whole angle. And they are by CPCT. They are by CPCT. So that's what I've written. Angle C is equal to angle B, CPCT. Angle C is equal to angle B, CPCT. So that means when two angles are equal, the sides opposite to them are also equal. The sides opposite to them are also equal. So the side opposite angle C, the side opposite angle C is AB in the whole triangle. Now we are taking the whole triangle. In the whole triangle, the side opposite to angle C is AB. And the side opposite to angle B is AC in the whole triangle. In the whole triangle ABC, angle C and angle B. So AB, AC. AB is equal to AC. Sides opposite to equal angles are equal. No, I'm scared. No, actually, I'm not able to comfortably go ahead. See, proving congruency, I hope you all understood. Congruency, you all understood. Now see here, look at this whole figure. Look at the main figure. You can see that in triangle BCF, look at the figure given in the question. In triangle BCF, do you see angle B fully or angle C fully? In triangle BCF, don't take time to answer.
Angle C, ma'am.
In triangle BCF.
Angle B, ma'am.
In triangle BCF, you can see angle B only fully. C is only, see, fully meaning that whole triangle ABC we have, right? That whole triangle ABC, angle C, you can see only a little in BCF, but angle B you can see fully. See here, BCF triangle, C is only this much, but actually C is this full angle. But in BCF triangle, you can see angle B fully because BCF, no, see, draw the triangle BCF and see this angle B is full. You can see the whole of angle B. And in the other triangle, BEC, see the main figure, BEC, angle C you can see fully, angle C. This is what we are proving are equal. Angle B is equal to angle C. Once we prove that these two triangles are congruent, 90 degrees in both the triangles, common hypotenuse and some other side, altitudes are equal. So RHS rule, the triangles are congruent. CPCT, you get this result. This angle is equal to this angle. I told you number it. Number the angles and then you will see that this and this one will have the same number. So those angles are equal. Now we got angle B is equal to angle C, right? Now leave this figure. Take the whole triangle ABC. Take the whole triangle ABC. We have proved, see, in some other way, we have proved angle B is equal to angle C. We proved this angle B is equal to this angle C. Use that information in the whole triangle ABC, not in these triangles. We got the result angle B is equal to angle C from these two small triangles. Use that information in the whole triangle ABC. Use the theorem, sides opposite to equal angles are also equal. So now AC is equal to AB. That's what we get. AC is equal to AB or AB is equal to AC. Yes, so we got this one. Next, I told you, you can take up with, I have taken two triangles with the side AC. You can take two triangles with the side AB also. You can take two triangles with the side AB, BC and AC. So I have any two is enough. We can take three pairs of triangles, take any two, that's enough. So I have taken ACD and ACF and in the same way, same RHS rule. You will have the same thing, one common side, right angle and altitudes are equal. So RHS rule, the triangles are congruent. And from the two triangles, let me draw those two triangles, ACD, ACF. ACD, ACF, ACD, where is it? Yeah. Same thing. Okay, so ACD and ACF. So you can see that in these two triangles, we have angle C and angle A completely. No, angle A is not complete. Is it in AC? Yeah, in ACF, we have angle A completely. Yeah. See the main figure. ACF, see the main figure. See it, ACF. Let me remove this. This is only ACF. ACF. See, you have angle A fully. And in ADC, you have angle C fully. Now, this is what you'll have to prove are equal by CPCT. So we have 90 in both the triangles. The altitude AD is equal to the altitude CF. And AC is equal to AC, common side. AC is equal to AC, common side. So right angle in both the triangles. Hypotenuse, which is a common side. AC is a common side. And then RHS, some other side. Altitude AD is equal to the altitude CF. So RHS, the triangles are congruent, CPCT. Now tell me the order, children. How will you write this? If you say ADC, congruent to what?
AFC.
If you say ADC?
AFC, ma'am.
AFC, is it? No. AFC, ma'am. Okay, one minute, wait. You're saying AFC, right? Let me just write that.
CFA.
Yeah, it is CFA. So I'll just take the information from here itself. See here. Okay, fine, let's do it. What are the information we have? Angle D. Angle 1 is, I'll just number it 1 and 2. Angle 1 is equal to angle 2. Angle 1 is equal to angle 2, 90 degrees. And then we have hypotenuse AC is equal to hypotenuse AC. And some other side AD is equal to CF. Now, how I told you, take up that information. AC is equal to take up these two information. Take up these two. Now what's common there? In this one, A is common. So write CAAD. Write CAAD. Remember this, children? Don't remember? A is common. ACAD, A is common. So write it as CAAD. And then here C is common. So ACCF as it is, ACCF. So it will be CAD congruent to ACF, ACF. CAD, ACF. If you want to write ADC, say ADC. If you want to write ADC, you must say it's congruent to CFA, CFA. Okay, now this is the correct order. These two are correct. Now let's mark the angles. Now CAD, let's mark CAD in this triangle, CA and D in this triangle. C is this one, angle 1. Okay, I've already used 1 here. This is a different thing, children. I'm marking again. C up, CAD. Okay, so C I'm marking 1, A I'm marking 2, and D I'm marking 3. Now take the other triangle. Take the other triangle. There also. Okay, ACF. A is 1, C is 2, and F is 3. All right, so you can see now angle 1 is here. So this angle 1, that is this angle C is equal to this angle 1A. C is equal to A, CPCT. Then this angle is equal to this angle CPCT. This angle is equal to this angle, we already know. You can see that 3, 3. The angles marked 1, 2, 3. They are the results by CPCT. But 3 we already know. So the angles marked 1 here is equal to 1 there, CPCT. 2 here is equal to 2 there, CPCT. So we want this one, angle C is equal to angle A. We want that. C is equal to A. That's what I've written here. Angle C is equal to angle A, CPCT. Angle C is equal to angle A, CPCT. So in the triangle ABC, C and A, opposite side, BC is equal to AB. BC is equal to AB. The side opposite to angle C is AB. Angle C, the side opposite to angle C is AB. AB is equal to the side opposite to angle A is BC. So AB is equal to BC. So now we have AB is equal to AC, AB is equal to BC. That means all the three are equal. AB, BC, AC, all are equal. That means the triangle is equilateral. Which means the triangle is equilateral. Understood, children?
Yes, ma'am. Yes, ma'am.
Yeah. Raja and Srijana, you both did not complete the homework.
Ma'am, sorry ma'am, I just sent it right now, ma'am. Before the class. Extremely sorry for the delay, ma'am.
Why, what kept you so busy? Okay, Srijana, what about yours?
Ma'am, I finished the work, ma'am. I will submit after this class, ma'am. Today morning only I came, ma'am.
Okay. I'll let you go. Yeah. So here in the figure, ABCD is a square. And EF is parallel to the, you can see there, EF is a line segment. EF is parallel to the diagonal BD. And EM is equal to FM. As you read, you must see that, that part in the figure. ABCD is a square. Yeah, we can see that. EF is parallel to BD. Okay, EF is parallel to BD. And then EM is equal to FM. Okay, prove that. That's all. Only one we have to prove. 1 second.
Ma'am, the second subdivision is missing in the question.
Yeah, that's what. AM bisects BAD, right? That's what. I've written here. I forgot. I missed it here. Okay, so these are the two things we'll have to prove, children. Prove that DF is equal to BE and AM bisects BAD. Yeah, as Madhumita said, that's missing here. The second one is missing here. Okay, so AM bisects angle BAD. These are two things we'll have to prove. DF is equal to BE. And AM bisects BAD, which is AM, this AM, bisects BAD, this angle. This angle is bisected by AM. This angle is bisected by AM. All right. So I hope you got the information given. So now to prove that, DF is equal to BE, DF is equal to BE, this one. That's quite simple. Just a minute, children. Yeah, sorry, and thank you, children. Yeah. So the first thing is the second subdivision. I don't know where I stopped, so I'm coming from the beginning. So the second subdivision is not, given in the question. So please make a note of that, include that. Fine. So we have to first prove that DF is equal to BE. DF is equal to BE, is equal to BE. And then we'll have to prove that AM bisects angle BAD. AM bisects angle BAD. So BAD is this full angle. This full angle is BAD. AM bisects BAD. What's the measure of this angle, children? What is the measure of this angle?
90 degrees, ma'am.
90. So you must prove that this one AM bisects the corner angle A. Okay, you don't have to find the magnitude. I just asked you what the measure of that angle is, because it's a square. Every corner is a right angle. Every corner is a right angle. All right, children, let's get started now. So first, so what we're going to do is we're going to prove that 1 minute. Let me come from behind. Okay, is okay. Let me use. There's no place there. Yeah. Now just acknowledge whatever I write. Is this correct? Is this correct? Is DC is equal to BC? Is this correct?
Yes, ma'am. All the sides of a square are equal.
Now we'll prove that CF is equal to CE. Okay, we'll prove this. CF is equal to CE, we'll prove. Now what will you get when you subtract? This we know, this we'll prove. CF is equal to CE, we'll prove. Now when you subtract, what do you get? What is DC minus CF?
DF, ma'am.
DF is equal to, what is BC minus CE?
BE.
BE. This is what we'll have to prove. This is what we'll have to prove. Yeah, DF is equal to BE. You can see that DF is equal to BE. So remember that. So to prove that DF is equal to BE, actually you can take up, if you have sufficient information, you can take up these two triangles also. Where do we have DF? We have DF in this triangle. We have DF in this triangle. And we have BE in this triangle. We have BE in this triangle. So you can check. You can check if you have sufficient information to show that these two triangles are congruent. If we have sufficient information, yes, we can take up these two triangles and show that they are congruent, and hence DF is equal to BE. Okay, so you can think about that later. So this is, you can take up, because DF is in triangle ADF. DF is in triangle ADF, and BE is in triangle ABE. ABE. So you can take up these two triangles, show that they are congruent, hence BE is equal to DF. That's possible. Just think about it. If we have sufficient information, they may be congruent, but you should have information to show that they are congruent. So think about that. Okay, so if you have sufficient information that caters to a particular congruence criterion, yes, then you can prove it that way. So then you will get DF is equal to BE. So you think about that. Okay, so now what we're going to do is we already know that DC is equal to BC, because in a square all the sides are equal. We're going to prove that CF is equal to CE. We're going to prove that CF is equal to CE and subtract these two results. So we'll get DF minus CF is DC minus CF is DF is equal to BC minus C is B, like this. Now let me, it's difficult, children, to use that slide and teach, so I'll just number the angles in a different way. So now first what I'm going to do is, please don't match the, okay, let me take the same numbers. 1, 2, 3. No, that's going to take time. I'll just mark it in a different way. So now first look at this, children. Are these two lines parallel? These two lines? Is this one parallel to this one?
Yes, ma'am. Yes, ma'am.
It's given.
Yes, ma'am.
This is the transversal, right? This is a transversal.
Yes, ma'am.
Yeah. Now, I think we spoke about the corresponding angles in detail in one of the last classes. So how do you identify a pair of corresponding angles? Corresponding angles are a pair of interior and exterior angles. A pair of interior and exterior angles on the same side of the transversal, but they should not form a linear pair. Corresponding angles are a pair of interior and exterior angles on the same side of the transversal, but they should not form a linear pair. So you can see here, this is a, yeah, you can see that this is the parallel lines and the transversal like this. Okay. So I'm talking about this angle and this angle. This is an interior angle. This is an exterior angle. They're on the same side of the transversal and they don't form a linear pair. So where are those angles here? Here and here. These two angles. They're corresponding angles. All right. These two angles are corresponding angles and they're equal. So I say angle 1 is equal to angle 2. Angle 1 is equal to angle 2. All right. All right, children. Angle
Yes.
1 is equal to angle 2. Okay. Now, what do you say about triangle BCE? No, not BC, BCD. Triangle BCD.
Ma'am,
It's
AE
isosceles.
is- Yes, ma'am.
BCD is isosceles. Correct?
Yes.
BCD is isosceles. That means in a triangle, when two sides are equal, two angles are equal. So let me mark this angle 3. Let me mark this as angle 3. So in triangle BCD, BC is equal to DC. So
Angle 2 is equal to angle 3, ma'am.
angle 2 is equal to angle 3. Angle 2 is equal to angle 3. Now, what is our intention? We are trying to show that this, what is our intention? We are trying to prove that we need to get this result. What is the result we need to get? We need to get CE is equal to CF. Okay, we need to get this information. CE is equal to CF. So we are trying to show that we are trying to prove that this angle is equal to this angle. We're trying to prove that this angle is equal to this angle. These two angles are equal. These two angles are equal. Yeah, children. 1 minute, children. Again, somebody's bothering me. 1 second. Yeah. Yes, children. So we're trying to get this information that CE is equal to CF. Okay. Now see here. Again, these two lines are parallel, the same two lines, but this is a different transversal. We're going to take up a different transversal. See, these two lines are parallel. Look at this transversal. This one is a transversal. This one is a transversal. So this angle 3 is equal to, let me call this angle 4. This angle 4. Again, same reason. Corresponding angles are equal. Angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Corresponding angles are equal. Angle 3 is equal to angle 4. Corresponding angles are equal. So what is that? How did we get angle 1 is equal to angle 2? Angle 1 is equal to angle 2 because we are given two lines are parallel and considering the transversal CB. Considering the transversal CB, these two lines are parallel. These two lines are parallel and BC is the transversal. Corresponding angles are equal. So we get angle 1 is equal to angle 2. Take the same set of parallel lines, but a different transversal. Different transversal, that is DC. DC is a transversal. You get angle 3 is equal to angle 4. Same reason. Corresponding angles are equal. This 2 is equal to 3. How do we get this triangle DCB is isosceles? Because two sides are equal. DC is equal to BC. DC is equal to BC. All the sides of a square are equal. DC is equal to BC. So we get by isosceles triangle property, angle 3 is equal to angle 2. That's how we get this information. So two pairs of corresponding angles, parallel lines, same set of parallel lines, but different transversals. So we get two pairs of corresponding angles equal, and then angle 2 is equal to angle 3 by isosceles triangle property. Now compare all these results to them. We need to show that 1 is equal to 4. We need to show that 1 is equal to 4. So where is it? We need to show that angle 1 is equal to angle 4. See here, angle 1 is here, angle 4 is here. Now see here, 4 is equal to 3. Angle 4 is equal to angle 3. And angle 3 is equal to angle 2. That means if angle 4 is equal to angle 3 and angle 3 is equal to angle 2, that means 4, 3, 2 all are equal. And 2 is equal to 1. That means all these 4 angles are equal in measure. See here, 4 is equal to 3. Okay, and 3 is equal to 2. That means 4, 3, 2 are equal. But 2 is equal to 1. That means 4, 3, 2 and all these 4 angles are equal. Just take some numbers. Now, supposing I say angle 4 is 50 degrees. Then what's the measure of angle 3?
50 degrees.
50 degrees. Then how much is angle 3 here?
50 degrees.
50 degrees. Then how much is 2 here?
50 degrees.
50 degrees.
Then if 2 is 50 degrees, how much is this 2?
Same 50 degrees.
50 degrees. Then angle 1 is also 50. So you can see that all the angles are equal. So we get this information. Angle 1 is equal to angle 4. Angle 1 is equal to angle 4. So like this, we prove that angle 1 is equal to angle 4. Now, if angle 1, see, this is angle 1, this is angle 4. Angle 1 is equal to angle 4. So that means these two sides are equal. In this triangle, two angles are equal. So by now, you know that should be, something very basic for you. In a triangle, when two angles are equal, the sides opposite to them are also equal. So opposite of this angle is this side, opposite of this angle is this side. So we proved that this angle is equal to this angle, and hence this side is equal to this side because opposite. So we got that information now. That's what we wanted. We wanted to show that this side, this part is equal to this part. So now we already know that DC is equal to BC. We have proved that CF is equal to CE. On subtracting these two information, DC minus CF is DF. BC minus CE is BE. All right, children?
Yes, sir.
Yeah, so let me, you also go through. Let me just check if I've not typed it correctly. So EF parallel to BD and CD is a transversal. Or CD is a transversal corresponding angles. EF is parallel to BD. CB is a transversal angle 3 is 4. Okay. In triangle BCD, CD is equal to BC. So CD is equal to BC. Yeah. So I think I can write it like this because opposite to CD is angle 4. So let me write BC is equal to CD. BC is equal to CD. In triangle BCD, BC is equal to CD. So opposite to BC is angle 2 and opposite to CD is angle 4. So 2 is equal to 4. All right. Then from ABC, all the angles are equal. So we'll just take what we want. Angle 1 is equal to all the 4 angles are equal. From A, B, and C, all the 4 angles 1, 2, 3, 4, all of them are equal. But we'll just take what we want. Angle 1 is equal to angle 3 in triangle CEF. In triangle CEF, correct. So this implies CE is equal to CF. Correct. Then I've not completed it. Oh my God. Oh, I've started congruency here all of a sudden. Sorry. Oh, I've not completed this one, children. Sorry, that's why I wanted to check. Oh, after this, I've not completed this. Sorry. Shit. I think you finished writing all this in your book, right?
Yes,
Children?
ma'am.
Oh yeah, please make this corrections here. Not till here is fine. Till here is fine. Then I've not completed this proof. I don't know why I went off to congruency and okay, this part I'll correct it when I read that, children. Now after this, all of you make a note in your book. After this one, you must write. After this, you must write. Okay, BC. You must write BC is equal to CD. In the bracket, sides of the square are equal. Then you got CE is equal to CF. We just proved no CE is equal to CF. Should subtract these two results. On subtracting these two results, BC minus CE is BE is equal to CD minus CF is DF. So like this, you get B is equal to DF. Please complete this, children. I have not completed.
Completed, ma'am.
Yeah. Yeah. Okay, children. Now, the next thing, we have to prove that okay. Next, we'll have to prove that AM bisects angle BAD. All right. So for that, I'll just tell you how the proof goes and then I'll check it. We have to take up this triangle. We'll have to take up this triangle and this triangle and show that they are congruent, children. Okay. Let's do this one first. So ADF and ABE. ADF and ABE. We'll have to take up these two triangles and show that they are congruent. So how do you show that they are congruent? See, AD is equal to AB because ABCD is a square. Then this is 90 degrees. Finding my point. Yeah, this is 90 and this is 90. That's what it is. Angle G is equal to angle B, 90 degrees. Okay. And then we have already proved that DF is equal to BE. That is what you should write. What have I written? You have written something here. Don't write all this, children. Probably I was sleepy when I was doing this, so I've just made some mistake. Sorry, don't write all this. We have proved that DF is equal to BE, right? DF is equal to BE. That's what you should write. Because we already proved this. DF is equal to BE. That's the third information. Proved. This one is proved. Children, I repeat the information. Take up these two triangles. AD is equal to, see this triangle and this triangle. Okay, AD is equal to AB, sides of the square are equal, 90 degrees. 90 degrees, every corner of a square is a right angle. And then DF is equal to BE, which we already proved here in one. Which we already proved in one. Not all this. Take away all this, only this. Reason is proved. So the two triangles are congruent by SAS rule. ADF, ABE. Yeah, that's correct. Angle 5 is equal to 6 CPCT. Everything is fine, children. Just take out this part, that's all. Am I clear?
Yes, ma'am.
Yeah, so angle 5 is equal to angle 6 CPCT. Now, children, the same way, take up these two triangles, this one and this one. Okay, show that they are congruent. Again, we have all information. Now, in this triangle, see, in this triangle and in this triangle, Okay, so AM is the common side. AM happens to be the common side. We got one information. And then AF is equal to AE. AF is equal to AE because we proved that these two triangles are congruent, right? So CPCT AF of this triangle will be equal to AE of this triangle. See, we don't know. We are not given that AF is equal to AE. But since these two triangles are congruent, we have AF is equal to AE. That's another information. We clear the screen. Okay, so in these two triangles, in this one and this one, AM is the common side. AF of this triangle is equal to AE of this triangle because we proved that these two triangles are congruent. So CPCT, we have this side is equal to this side. And then we already know that EM is equal to FM. We already know that EM is equal to FM. EM of this triangle is equal to FM of this triangle. So SS is, so let me see if I've written correctly. AF is equal to FE. AF is equal to AE CPCT from ADF congruent to AB. This is correct. FM is equal to EM given. Yeah, FM is equal to EM given, correct. AM is common side. Yes. AFM congruent to AEM, correct. SSS. So angle 7 is equal to 8 CPCT. Yes, children. So from the congruency of these two triangles, we have CPCT. Angle 7 is equal to angle 8. Angle 7 is equal to angle 8. All right.
Yes.
Now we need to add these two results, children. Now we need to add, we got 5 is equal to 6 and 7 is equal to 8, right? Add these two results. So like this, angle 5 is equal to angle 6, angle 7 is equal to angle 8. So add them. Angle 5 plus 7 is equal to 6 plus 8. Angle 5 plus 7, write it one below the other and add. So, or it's like what I have done is I've added the LHS and RHS. Angle 5 plus angle 7 is equal to angle 6 plus angle 8. So 5 plus 7 is nothing but this full angle, DAM. And 6 plus 8 is this full angle, BAM. So we have proved that this DAM, this angle is equal to this angle. That means AM by 6, AM by 6, DAB or BAT. We have proved that this part is equal to this part. That is the two parts on either sides of AM. This is AM. This is AM. On one side of AM, we have this angle. On the other side of AM, we have this angle. And we prove that those two angles are equal. So that means AM by 6, BAT. All right, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay, so in this figure, OA is equal to OD. In this figure, OA is equal to OD. OA, you see this one, OA is equal to OD. Okay. And angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Prove that triangle OCB. What is OCB? OCB. Okay, OCB, this triangle, OCB. Prove that this triangle, OCB, is isosceles. Prove that this triangle is isosceles. That means you can either prove that this side is equal to this side. So it's isosceles. Or this angle is equal to this angle. So depending, whatever you can do. You can show that this side is equal to this side. So when two sides are equal, OBC is isosceles. Or OCB is isosceles. All right, children. So what you can do is you can take up this triangle and this triangle. OA. See, I'm taking these two small triangles, AOC and BOD and BOD. AOC and BOD. Okay. So in the first triangle, AO is equal to DO on the second triangle. Because it's given. It's given. And then you can see that these two lines are intersecting, right? These two lines are intersecting. So vertically opposite angles are equal. Vertically opposite angles are equal. So this angle of this triangle is equal to this angle of this triangle. How much they measured, we don't know. We don't know how much they measure, but they're equal. They're equal because they're vertically opposite angles. So what did we get? We have this angle is equal to this angle. Vertically opposite angles are equal. Then OA is equal to OD. That's given. Which are the two triangles we have taken up? We have taken up this triangle and this triangle. This triangle. So this side is equal to this side. This angle is equal to this angle. And then we know that angle 1 is equal to angle 2. But that,
angle D, ma'am.
yeah. Somebody's mic is enabled. Now Sanjay spoke, but somebody's mic is enabled. Please disable your mic. Okay. All right, children. So if I call this one 3 and 4, if I call this 3 and 4, what is angle 1 plus 3, children?
180 degrees, ma'am.
Sorry, what is angle 2 plus 4?
180 degrees.
So that means angle 1 plus angle 3 is equal to angle 2 plus 4, right?
Yes, ma'am.
Yes.
So now you can cancel 1 and 2 on both the sides because they're equal. So or you can write angle 1 plus angle 3 is equal to 2 is also 1 plus angle 4. 2 can be written as 1 because 1 and 2 are equal angles. 1 is equal to 2. So 1 gets cancelled on both the sides. So you get angle 3 is equal to angle 4. No, I don't know how I've done here. Oh, okay. I'll explain that also. You can take it like this. So angle 3 is equal to angle 4. Understand this, children?
Yes, ma'am.
So that's that's the other information. Angle 3 is equal to angle 4 is the other information. So by ASA, you can see two angles in the included side. By ASA, see 1 is equal to 2 is an information, but that you cannot use directly in these two triangles. Okay. So yeah, 1 is equal to 2 cannot be used directly. So you get 3 is equal to 4 like this. ASA rule, the two triangles are congruent. So what I've done here is this is also fine. So see here. Angle 1 is equal to angle 2, right?
Yes, ma'am.
Yes, ma'am.
Yeah. Now we are subtracting both the angles from 180. So 180 minus angle 1 will be equal to 180 minus angle 2. Angle 1 is equal to angle 2. We are subtracting both the angles from 180. 180 if angle 1 is equal to angle 2. 1 minute. Yeah. If angle 1 is equal to angle 2, you can subtract both the angles. That is subtracting both the sides from 180. So 180 minus angle 1 is equal to 180 minus angle 2. So what is 180 minus angle 1? Angle 3 is equal to, what is 180 minus angle 2? Angle 4. Angle 4. You can also do this. All right, children?
Yes, ma'am.
Yes. Let me write this here. See, you can do it like this, or what you can do is angle 1 plus angle 3 is equal to 180, linear paraxium. Angle 2 plus angle 4 is also 180, linear paraxium. So we have angle 1 plus angle 3 is equal to angle 2 plus angle 4. But we know that 1 is equal to 2. You can directly cancel or you can replace 1 plus 3 is equal to 2 is nothing but 1 because 2 and 1 are equal. So angle 1 plus angle 4. Now we cancel out angle 1 on both the sides and we get 3 is equal to 4. You can also do it like this or this. So ASA rule. The two triangles are congruent. Yes or no, children? Any questions?
No doubts.
The same thing, whatever I said is what is on the screen. All right. Make a note of this. I'll just wait for some time. Yeah.
Completed, ma'am.
Yeah. Yeah, this is what I shared as homework, right?
Yes,
Ma'am.
Yeah. So 4 I've done it in 2 ways. Yeah, so I'm going to explain this one. This one is similar, children. We have done this. I think there it was a square, but the proof is the same, not even similar. It's the same. You go through your classwork notebook. The same question, it will be in a square ABCD. Here it's a rhombus. That's the only difference. Probably there we have to prove that DOB is a straight line. So here we are proving that DO and B are collinear. DO and B are collinear. Probably there prove that DOB is a straight line. So similar one, you can just look into your classwork. Sum of all the angles around O is 360. I remember. I'm very sure. Okay, so we have done a similar one. So I'm not explaining this. I'll do the sixth one, and I'll do the fourth one, both the methods. This is similar to what you just saw. What we just understood. So what's the other way of proving angle 1 is equal to angle 2? Tell me. We have angle 5 is equal to angle 6. We have angle 5. See, we are given angle 3 is equal to 4 and 5 is equal to 6. How do you prove that 1 is equal to 2?
Angle 5 plus angle 1 is equal to 180 degrees.
Angle 1 plus angle 5 is equal to 180.
Angle 2 plus angle 6 is equal to 180.
Plus 6 is 180.
And angle 1 plus angle 5 is equal to angle 2 plus angle 6.
Plus angle 6.
And since angle 5 and 6 are equal, it becomes angle 1 plus angle 5 is equal to angle 2 plus angle 5.
Very good.
And then angle 5 gets cancelled, so we get angle 1 is equal to angle 2.
Very good. That's all. We just did that, no? Thank you, Madhumita. Very good. So you can prove 1 is equal to 2 like this because we are given 5 is equal to 6, but we cannot use that information in the two triangles. 5 is equal to 6 should be converted to 1 is equal to 2 like this. Because 1 and 2 are a part of the two triangles. 5 and 6 are exterior angles. So you convert 5 is equal to 6 to 1 is equal to 2 like this. So all these ideas, are very important. Done, children?
Yes.
Yes.
You can open this answer in your book and make a note of this. So next class, Tuesday, we'll finish congruent triangles. I have some more, proofs to share with you. I'll share the images by tomorrow, not by tomorrow, by tomorrow morning, so that you can, work out all that in your notebook. But those will be explained on Tuesday, and Tuesday we'll wrap up congruent triangles and continue with Heron's formula. So Tuesday also, I will not be doing every other proof. Whatever is important, similar ones, there might be a few similar ones, or direct, directly given the information and just writing it out and showing that they're congruent. Such proofs I'll not be doing. Only the ones which I feel needs an explanation will be dealt in the class. So for sure, we'll wind up this chapter on Tuesday and continue with Heron's formula. If we have time on Tuesday, otherwise Thursday.
Yes, ma'am.
Yeah. All right. So that way 1 is easy. 2, 3, I did not share, right? No, I did not share 2, 3, I remember. Yeah, now we'll do 4. I said I'll do 4, both the methods. 5, already done earlier. And 6, I'll do it now. Okay. So what I'm going to do is I'm not going to read all that which is here for you. I'll just tell you how the proof goes. All right. Yeah. So first is how to make the diagram. Triangle ABC and triangle PQ. In triangle ABC and triangle PQR. AB is equal to PQ. So we have two triangles, ABC, PQR. ABC, PQR. Okay, AB is equal to PQ. AC is equal to PR. And altitude AM is equal to the altitude PN. Okay. Show that triangle ABC is congruent to triangle PQR. ABC is congruent to PQR. So if you take up the whole triangle ABC, the whole triangle ABC and the whole triangle PQR, you will realize that you don't have sufficient information to show that they are congruent. Okay, ABC, PQR, you take up the whole two triangles and try to write out the equalities, you will see that you're short of one equality. You have two things. You are short of one equality to complete congruency. So what you have to do is you have to take up this triangle and this triangle, show that they are congruent. Then take up this triangle. I'm doing it fast. Please try to understand. Then you'll have to take up this triangle and this triangle, show that they are congruent. Now, when you take up these two triangles and show that they are congruent, what will you get? One right angle you have and hypotenuse equal. We have right angle. See a right angle in both the triangles. Then hypotenuse equal because it's given. And this side AM is equal to PN because it's given altitude AM is equal to altitude PN. It's given there. It's given that the altitude AM is equal to the altitude PN. So when you take up this triangle and this triangle, right angle in both the triangles, then this side is equal to this side given and AM is equal to PN is given. So by RHS, right angle, hypotenuse and some side. RHS rule, the triangles are congruent. CPCT, you can write two things. You can write this angle. Okay, if I mark it 1, you can write angle 1 is equal to angle 2. Through CPCT, you can write angle 1 is equal to angle 2. Or you can write BM is equal to QN. Write any one. Or you can write BM is equal to QN. Write any one. Okay, you can write BM is equal to QN, CPCT. Or you can write angle 1 is equal to angle 2. Done. Now take these two triangles, this cross, this one and this one. Again, here the two triangles are congruent by RHS rule. Because right angles here 90 degrees, 90 degrees. Right angle, hypotenuse here AC is equal to PR given. And some other side AM is equal to PN. So right angle, hypotenuse and some side AM is equal to PN. The two triangles are congruent. So CPCT, you can write. If you have written 1 is equal to 2 earlier, you must write 3 is equal to 4 now. If you have written BM is equal to QN earlier, you must write MC is equal to NR now. That is important. If you earlier wrote angle 1 is equal to angle 2, now from these two triangles, you must write 3 is equal to 4. If you had earlier written BM is equal to QN, now you must write MC is equal to NR CPCT. Am I clear?
Yes, ma'am.
Yeah.
Yes,
Now,
ma'am.
very good. Now, when you add these two results, what do you get? What is 1 plus 3? Angle BAC. What is 2 plus 4?
Angle QPR, ma'am.
QPR. What is BM plus MC?
BC, ma'am.
What is QN plus QN plus NR?
QR.
Yeah. Now take up the triangles. Now we are done. Now take up the triangles ABC and now take up the triangles ABC and PQR. The whole triangles ABC and PQR. Okay. So AB is equal to PQ given. AC is equal to
PR, ma'am.
PR given. Thank you. PR given. Now, if you have written this, you write this. BC is equal to QR. So that will make SSS. BC is equal to QR. So that will make SSS. Or if you write this one, if you write this one, it will be SAS. Because you're saying this angle is equal to this angle. You have to write these two. And if you have found this, it will make SAS. If you found this, it will make SSS. That's what I've done here. Correctly. See that? This is SAS, children. Yeah, this is SAS. Sorry. Otherwise, I think it should be right. Angle 1 is equal to 90 degrees. 1 is equal to 290 degrees and AB is equal to PQ. Altitude AM is equal to PM. 3 is equal to 4 CPCT. 7, 8 AC PR, AM PN. 5 is equal to 6. BAC QPR in the two triangles. Yeah, SAS. I by mistake have written this one as SAS, children. All right. Do that correction. The congruence rule is SAS. That's all. Here I've taken the two triangles. Result congruency is by RHS only. But CPCT I've written BM is equal to QN. BM is equal to QN. And then the other one I've written MC is equal to NR. MC is equal to NR. So when you add both, you will get, when you add both, you will get BC is equal to QR. So if you use that information, it's going to be SSS. It will be SSS. All right, children?
Yes, ma'am.
Yeah. So it's actually this triangle, congruency. Then write either this angle is equal to this angle, or you write this side is equal to this side. Then you should take up this triangle and this triangle, prove that they are congruent. If you have written these two angles are equal, you must write angle 5 is equal to angle 6. If you have written BM is equal to QN, you must write MC is equal to NR. Right? Any one of the two. So if you have written about this angle and these angles, then it will be finally it will be SAS. If you have written about these sides, it will be SSS. Let's come back to you 1 second. Yeah, children. So here we are given that BL is perpendicular to AC, BL is perpendicular to AC, and MC is perpendicular to LN, and AL is equal to CN. AL is equal to CN, and also BL is equal to CM. All right. So given all this, we need to show that the whole triangles, ABC and NML are congruent to each other. Just 1 second. Yeah, children. Yeah, so we have to prove that triangle ABC is congruent to triangle NML. This whole triangle ABC is congruent to NML. Okay, so again here, look at the information we have to show that the whole two triangles are congruent. We have only this portion, equal to this portion. We have this one equal to this one, and we have 90 degrees. We have So we have 90 degrees, nothing else we have. See, 90 degrees we cannot use because it is this whole triangle. For this whole triangle, these are for this whole triangle, these are the angles. These are the angles, and these are the sides. This is one side, this is one side, this is one side. And in the other triangle, these are the angles. These are the angles, and these are the sides. AB is one side, BC and AC. So practically this 90 degrees is not going to help us at all. This 90, though this is 90 here, it's not going to help us because they're not angles in the two triangles which we have to prove are congruent. Similarly, you can see here AL and CN, they're only little of the two triangles. And this is also useless. This one is equal to this one. We can't write that. We cannot write that. So practically, we don't have any information at all to show that these two triangles are congruent. We only have AL is equal to CN, which can be modified. AL is equal to CN. We only have AL is equal to CN. And you can add LC to both the sides. You can add LC to both the sides. AL is equal to CN, okay? And you can add this common portion to both the sides. LC to both the sides. So what is AL plus LC? AC. AL plus LC is AC. And what is CN plus LC? CN plus LC is NL or LN, which is the side of this triangle. When you see, we have AL is equal to NC. When you add LC to both the sides, you will get AC of this triangle is equal to NL of this triangle. So that one information you can generate from this one. Nothing else we have. So two more equalities we have to generate. From using AL is equal to CN, we can add LC to both the sides and get AC is equal to LN. One equality which is relevant to the two triangles. Nothing else we have. We have some other information, but not useful to show that these two triangles are congruent. So what we have to do, we'll have to generate two more equalities. Take up this triangle and this triangle. This and this, because see, both these triangles have a common side. So it's easy to show that they are congruent. These two triangles have a common side here. See, LC is a common side. So take up these two triangles and take up these two triangles. Show that they are congruent. Show that they are congruent. So that we have direct information. See here, this side of this triangle is equal to this side of this triangle. Then 90 degrees here, 90 degrees here. And then this side of this triangle is equal to this side of this triangle. It's all given. So SAS rule, the two triangles are congruent. CPCT, you will get AB is equal to MN. AB is equal to MN. AB is equal to MN. So we got one information. AB of the big triangle ABC is equal to MN of the big triangle MNL. Now take up these two triangles, this triangle and this triangle. See, LC is a common side. One information. LC is a common side. And then this one of this triangle is equal to this one of this triangle. It's given. It's given. And then it's 90 here in this triangle. It's 90 here in this triangle. So again, by SAS, side, angle, side. By SAS rule, the two triangles are congruent. CPCT will have BC is equal to MN. BC is equal to MN. Another pair of equal sides, which is relevant to the two triangles. From the first one, we got AB. From the first one, we got, when you prove that this triangle is congruent to this triangle, you got AB is equal to MN. Now, when we prove that these two are congruent, we get this side is equal to this side. And we can, I showed you, by adding, you can get AC is equal to LN. So now in these two triangles, all the three sides are equal. The three sides of one triangle are equal to the corresponding three sides of the other triangle. So SSS rule, the two triangles are congruent. So basically here we have only one information. This information can be developed and got into one information. AC is equal to NL. The other two you have to find. This congruent to this, you will get this side is equal to this side. This one congruent to this one, you will get this side is equal to this side. And then we already know that this is equal to this. So SSS rule, the triangles are congruent. Is that fine, children? That's what is here. Yeah, that is what is here. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you.
Thank you, children. Thank you, children. Thank you.